This is the first problem we're going to tackle together, and it says which positive value of x makes f of x equal to g of x. So if we were going to look at this on a graph, we would be looking for where those two lines intersect in the positive range. So we're looking in that first quadrant. So I have graphed these. Okay, so here's our equations. You can do this on Desmos for the ones that talk about equals, but on the EOC, they will be calculator inactive. So what we're going to do here is I'm going to show you how to do this by hand. It's pretty easy. So we just need to set it up by putting an x column, an f of x column, and a g of x column. And so what we're going to do, since it says positive value of x, we're going to start with our very first x value being 1. All right, and what we're going to do is plug it in. So 5 times 1 is 5, plus 6 is 11, and 4 times 2 to the x power. Remember, we do exponents first. So 2 to the first power is 2, and 4 times 2 is 8. So we are trying to figure out where these two things are equal, and they are not equal right here. So that's, nope, doesn't work. Move on. Let's go to number 2. Plug it in. 5 times 2 is 10, plus 6 is 16. 2 to the second power is 4, and 4 times 4 would be 16 as well. So we can see that it only took us one try. Our x value of 2 produced the exact same y value here. Okay, you may have to continue that pattern on and on. If you do have to continue the pattern, just remember linear patterns add, so we'd be adding 5 every time. And exponential patterns multiply, so we'd be multiplying by 2 every time. So you can use the pattern. You don't have to plug in numbers every time. Just get a couple numbers in your table and then use the pattern to keep filling it in if you need to. All right, so our second example is going to be one that is a little bit more complicated here, and we are going to be kind of comparing. So we're going to say which positive integer of x, I'm making a video for school, honey, makes f of x first become less than g of x. So it's a little bit more difficult when you have that less than or equal to as opposed to just an equals. When are they equal? So we're going to have to kind of play around with this, but we're doing the same process. So we have to know our equations. We're going to use 2x plus 1 this time for f of x. And for g of x, we'll use just 2 to the x power. All right, so remember, if you have something to the x power, this is your multiplier. The thing in front would be our y-intercept, and if we don't have one there, it's assumed to be a 1. So we really could kind of think about this as 1 times 2 to the x, but for mathematical purposes, it's easier just to do 2 to the x. So again, we're going to build our table. We have an x value. We're going to get an f of x value, and we're going to get a g of x value, and we're going to compare them. We want f of x to be less than or equals to g of x. So every time I want this to be the case, and if it's not the case, then that can't be our answer. So here we go. It does say positive integer, so I'm going to start with 1 since it wants me to use a positive number. And 2 times 1 is 2, plus 1 is 3. So again, I'm just plugging in. 2 to the first power is just 2. Is 3 less than or equal to 2? No, so we need to move on. We're going to pick our next value of 2. We're going to plug it in. 2 times 2 is 4. 4 plus 1 is 5. 2 to the second power is 4. And again, this does not satisfy our solution. Number 3. 3 times 2 is going to be 6 plus 1 is 7. And 2 to the third power, 2 times 2 times 2 is 8. At this point, we have kind of flip-flopped and said now 7 is less than or equal to 8. So this is going to be our answer. The answer, though, is 3 because it says which value of x. So our answer is 3.